radicals and square roots. So today we're going to talk about radicals and work through just one or two problems. So let's start with some vocabulary. Okay. So what is a radical? Well, as you can see here, this here, well, that is my radical sign. Okay, that's my radical. Okay? It's kind of like that big check mark there. Okay? So next, let's talk about our index. So what is our index? Well, our index tells us the kind of radical we have. And it's this number right here outside of that radical sign. So for us, this is a radical of 3, an index of 3, but it could tell us, do we have a radical of 2, which is a square root, radical of 3, radical of 4, okay, etc. If no index is shown, so if we just see that square root sign or that radical, it is an index of 2, which makes it a square root. And then finally, we have our radicand. Okay? Our radicand is our expression underneath the radical sign. Okay? Notice that I did not say number, because underneath my radicand can include numbers as well as variables. Okay, so let's look at simplifying some examples. Okay? So here, let's start out. We're asked to simplify the square root of 81. Now, how did I know that that was square root? Well, look at the index. Remember, the index would be here on the outside. Does my index have a number? Do I see a number on the outside? There is one. I know it's just not written, but remember, if it is not written, it is an index of 2. And this tells me I have a square root. Now, what my square roots do is I'm just finding all and undoing all of my perfect squares. So remember what perfect squares are. It's any number times itself. So for example, we know that 4 is a perfect square, right? Because 2 times 2. So the square root of 4 is 2. We know 9 is a perfect square. So we know this perfect square of 9 is 3. 16. Okay, we know that's a perfect square of 4, 25. Okay, and we can continue this list for a very long way. Remember, perfect squares are just any number that is multiplied by itself. Okay, it's just pairs of numbers. So let's look at the first simplifying our square root of 81. So the first thing we want to do is we want to create a prime factorization tree. So I want to break this down. And I want to try to get into where I'm just seeing prime numbers. Okay, so first, let me show you what that looks like. So for 81, I know that 9 times 9 is 81. Okay, but I can break down that 9 even further. Okay, so we also know that 9 can be broken down to 3 times 3. 9 3 times 3. And the goal here is to take what is currently under my radicand and break them down into prime numbers. Okay. Now, the next thing is, as you can see, I cannot go any further than 3 times 3. Okay, 3 I can't break down any further. So the next thing is, because it is a square root with an index of 2, I want to group the pairs. And when I group the pairs, I'm going to circle them. Okay. So here I have a pair of 3s and I have another pair of 3s. Okay, so there is my second step. Now keep in mind, all of this is still underneath that radicand. Okay, so all of this is still underneath that radekin. I have not pulled anything to the outside of that radekin yet. So my third step here is I want to box anything without a pair. Well, my 9 I already broke down to 3 and 3, and I got 2 pairs. This 9 I broke down to another 3, 3. I got another pair. So everything that's still left in the radekin is all paired up. Okay. So my next step is I want to pull my pairs out and keep the singles in. Okay. So I'm going to pull my pairs out of the radekin and leave whatever was boxed, okay, whatever was single without a pair, remain that underneath the radekin. So here I have a pair of 3s. I'm going to pull that out. So I have 1 pair of 3s. And then I'm going to pull this second out. And there's my another. Okay. And now what is left under my radekin? Well, nothing. Okay. I've pulled just 2 3s. So the third thing is I'm going to simplify. Whatever I've pulled out to the outside of the radekin, I'm now going to multiply. So I have 3 times 3, and that's 9. Now that was an easy one because we already know the square root of 81 is 9. Okay, but I wanted to show you the steps of creating the prime factorization tree, grouping the pairs because our index is 2, which tells us it's a square root and we're trying to find the pairs. Boxing anything without a pair, which is in this situation, we had perfect squares, and then pulling them out and simplifying. So what happens if we do not have a perfect square? So let's take a look at this next example. Okay, here, let's simplify the square root of 48. So the first question is, how did I know it was a square root? We'll take a look at the index. Nothing there, so we know is an index of 2 telling me perfect squares. That's what I'm after, finding those perfect squares, finding those pairs, and pulling it out. So I have a square root. So let's start with our prime factorization tree. Now I can break down 48 in several different ways. So I think the first thing I can do is we know 6 times 8. Now starting with my 6, I can break this down to 3 times 2, right? And I'm just going to cross out my 6 so I can remember that I've already broken that down. My 8, I can break this down to 2 times 4. This 2 here is as low as it can go. Can't break that down any further. But my 4, we know perfect square there, 2 times 2. And so now I have broken down this 8 into all prime numbers. So I'm going to cross that out. My next step is I'm going to circle all of my pairs. So I have a pair of 2s here and a pair of 2s here. Okay. And then my 3, all alone, it's a single. I'm going to box that in, reminding me that that 3 is still there all alone underneath that radekin. So here is my radekin, right? Now I'm going to pull the pairs out. I have 1 pair of 2s, another pair of 2s, and then what's still inside my radekin in that box? Well, there's my 3, and I'm going to leave them. That's all that's remaining underneath that radekin. Now, one more step because we do need to simplify these 2 2s here. This is 2 multiplied by 2, so let me bring it up top just so you can see. I have 2 square root of 3, and now let's simplify. Multiply those together, so I'm left with 4 square root of 3, and that is my final answer.